3, 2, 1.
Okay, 150 divided by 30. What are some different ways we can think of this? Cortera showed me one as I was walking around. She said that she could write it as a fraction, like this. That works. What's another way, ZZ? Long division. So you're saying I could also represent it like this? Okay. Jesse, what's another way? So you thought about it additively. You just said, well, how many groups of 30 do I need? So 30 plus 30 plus 30 plus 30 plus 30, something like that. Oh, you stacked? Well, I mean, okay, same way. What do you think, Yared?
I put 30, and I added them when it was 60, and 60, and 60, and 60 was
okay. So you used a similar strategy to Jesse, but you used some grouping. You said 60 plus 60, 120.
Plus 30.
Okay. All those are good ways. ZZ, what's another way you can think about this? You try to figure out how many times 30 would divide into 150, and what do you get? 50? Okay. Well, you're not the only person to say 50. So some people said 50. What's a quick way I could check to see if 50 was the appropriate answer? How do you check division problems? You multiply. Okay, so if I wanted to check to see if 30 divided by 50 was really, or 150 divided by 30 was really 50, I would multiply 50 times 30. Okay, so I know that 0 times 0 and 0 times 5 isn't going to get me anywhere, so I can just go right on my tens place. If I'm in my tens place, what do I need to add to show that I'm 10 times larger? A 0. So what's 3 times 0? What's 3 times 5? Okay, so I know that 5 times 30 is 1,500. That's 10 times too large. Now, today, the moral of the story for today is we're going to use estimation. Everyone look over at the board. It says estimate. As a verb, it means roughly calculate or judge a number or quantity. As a noun, it's just a rough approximation or a judgment of how much there is, a number, a quantity. So whenever I'm saying estimation, and you might think to yourself, what the heck does he mean? I really just mean about how much. And we're going to use some number patterns to help us with our estimates. Another way I can think of 150 divided by 30 is 15 tens divided by 3 tens. Can everyone see that 150 really has 15 tens? Can everyone see that there are 3 tens and 30? Let's go back to how Cortera said I could write this. Now I know that anytime I have a like factor on the top and on the bottom, I can do what to it? I can cancel it out because anything divided by itself is always going to be 1, unless it's a 0, and then it will be a 0, just to throw me off. So I know that this is the same as saying 15 times 10 is equal to 150. 3 times 10 is equal to 30. Does everyone see the 10 divided by 10? If you're not looking at this right now, you're really kind of just putting yourself at a big disadvantage. I'm showing you a huge tool that you can use to simplify all the things that we're about to do. All the division, you can use this estimation technique, but you need to understand that anytime you see a 0 in a 0, that's the same as saying whatever this number is times 10, whatever this number is times 10. So I see a like factor, 10 divided by 10. What can I do to it?
You can cross it out.
Yeah. Bye-bye, birdie. Now I just have 15 divided by 3. What is 15 divided by 3?
5.
15 divided by 3 is equal to 5. Let's see if that works. What is 5 times 0?
0.
What is 5 times 3?
15.
What is 150 minus 150?
0.
So what is the quotient of 15 or 150 divided by 30?
5.
Anytime that you see a number with a 0 at the end divided by another number with a 0 at the end, what can you do? You don't have to think about it, just mark out the zeros. Now, what did you just do? You turned a 3-digit number and a 2-digit number into a 2-digit number and a 1-digit number. Where do you guys want to divide? Do you want to divide 3 digits by 2 digits? Or 2 digits by 1 digit?
2 digits.
The less numbers you have, is your math easier or harder?
Easier.
So what tool do we have now? Anytime that we see a 0 in the numerator, a 0 in the denominator, what do I have to do? Mark them out. If I see a 0 and a 0, mark it out. What if I had a different one, something similar? Let's say, what if I had 1,500 divided by 300? I see a 0, I see a 0. What do I do to the... Okay, now I see a 0, I see a 0. Now, I went from a 4-digit number, it's being divided by a 3-digit number, to a 2-digit number, it's being divided by a 1-digit number. What's easier? The smaller one. Now I could say, what about if you had this kind of division problem? 1,500,000 is being divided by 300,000. Who wants to divide that? Anybody? But what can I use with my number patterns? Bye-bye, 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 bye-bye. For every 0 you have on the top, you can get rid of a 0 on the bottom. For every 0 you have on the bottom, you can get rid of a 0 on the top. Now this only works, guys, this doesn't work like this. What if I had, could I mark out the zeros now? No, I could not, because they're not at the end. This only works if the zeros are at the end. And whenever we use estimation, we take complicated numbers like $1,500 is kind of close to 1,534, right? 300 is pretty close to 301, yes?
Yes.
So by using this estimate, I can figure out that 1,534 divided by 300 is approximately what number? What is 15 divided by 3? So I know that the answer here is going to be somewhere right around. So whenever I'm done with my division problem, if I don't have a number that's somewhere in the neighborhood of 5, I know that I've done it wrong. And in real life, whenever you're having to make critical decisions, you're going to use estimation a lot more than finding the exact number down to like the 100th of a gram or 1,000th of a centimeter. Estimation is going to give you a lot more efficient use of your time. So again, I'll keep saying it. 0 on the top, 0 on the bottom. If they're at the end, cross them out. Now,